Welcome to qnawire.
All right, so I see that you need help with this problem, and it says the data below is a Hurricane Irma's wind speeds at Key West Airport starting at midnight on September 10th, 2017, 8 hours since midnight. So what I did was I took that information and I put it into a table. So here we go. Here's my table so that you can visually see it better than listed the way that it is. So here is my hours since midnight and my wind speeds. And then it says, look at the two. So then it wants you to do an exponential model and a linear model. So I did both of those with their equations. Where I took the points, and you'll notice for both models, the points are in the same location. And let me just create those. So here is my exponential model and my linear model for both. And so then it says the following. Let me just move this over so I can make this one the exact same size so you can visually see it. Here we go. All right, so then it says, look at the two models and how well the curve fits the data of your chart. Also look at the predictions for the wind speeds after 20 hours. Which model seems more appropriate and why? Fill in the blank words: wind speed increase, linear, increase, dramatically, negative, decrease, exponential, the steadily, hurricane, decrease, dramatically, level off, and positive. So we need to figure out within 20 hours which wind speed is better. So to figure this out, what I would do is, let's take a look at the first one, the linear model. And so I have y equals negative 3.1664 times 20 plus 145.447. So 20 times negative 3.1664. So that would be negative 63.328 plus 145.47. So 47 minus 63.328. And y equals 82.142. And then the other one is y equals 182.11 e to the negative 0.051 times 20. So negative 0.051 times 20 is y equals 182.11 e, negative 1.02. Then what I would do is y equals, so it would be 10 times negative 1.02. So 182.11 times negative 10.2 times 182.11. Okay, so then what I would do is I would use my calculator and I would do that out, and I would get 66.6679. And as you can see, for 20 hours, so my exponential would be better because 66.6679 is between 80 and 48, when 82.142 is between 12 hours and 9 hours. So my exponential, so the exponential model seems more appropriate. My prediction for the wind speed at hour 20 using the exponential model, so that's the second word, is much closer to the actual 20-hour wind speed. The exponential model is closer fit for most of the data points than the linear model. So it goes exponential, 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 then linear in the next blank. The exponential model will blank over time, just like blank does the real world after a will decrease. So the exponential model will decrease over time, just like the hurricane model will continue to decrease steadily or drastically. So the exponential model will decrease over time, just like the hurricane does in the real world after a decrease. Well, the exponential model will continue to decrease dramatically and eventually become leveled off, which is impossible in a real world. Oh, wait a minute. No, the linear model will decrease over time. Wait a minute. So this is confusing. So the linear model will continue to decrease, which is impossible for the real world, where the exponential will decrease and level off, just like the hurricane would. So I hope that this video helps. This is the middle school math teacher signing